welcome back to the Comptia Network Plus course. One other thing that may be noteworthy, if the IP version 4 network that you are traversing is a situation that has a NAT translation point, it will break the tunnel encapsulation that we've created. In the following selection, a solution is discussed. Teredo. Teredo gives full IP version 6 connectivity for IP version 6 hosts that are on an IP version 4 network that have no direct connection to an IP version 6 network. Its distinguishing feature is that it's able to perform its function even from behind network address translation NAT devices such as home routers. The Teredo protocol performs several functions: diagnoses UDP over IP version 4, UDP version 4 connectivity, and discovers the kind of NAT present using a simplified replacement of STUN protocol. Assigns a globally routable unique IP version 6 address to each host. Encapsulates IP version 6 packets inside UDP version 4 datagrams for transmission over an IP version 4 network. This includes NAT traversal. Routes traffic between Teredo hosts and native or otherwise non-Teredo IPv6 hosts. There are several components that can make up the Teredo infrastructure. Teredo client, a host that has IP version 4 connectivity to the internet from behind a NAT device and uses the Teredo tunneling protocol to access the IP version 6 internet. Teredo server, a well-known host that is used for initial configuration of a Teredo. Teredo relay, the remote end of a Teredo tunnel. A Teredo relay must forward all of the data on behalf of the Teredo clients it serves, with the exception of direct Teredo client to Teredo client exchanges. Teredo host specific relay, a Teredo relay whose range of service is limited to the very host it runs on. Dual stack. This is the most common type of migration strategy. It allows the devices to communicate using either IP version 4 or IP version 6. This technique allows for one-by-one upgrade of applications and devices on the network. As more and more things on the network are upgraded, more of your communication will occur over IP version 6. Eventually all devices and software will be upgraded and the IP version 4 protocol stacks can be removed. The configuration of dual stacking on a Cisco router is very easy. It requires nothing more than enabling IP version 6 forwarding and applying an address to the interfaces that are already configured with IP version 4. It will look something like this. Corp config hash IP version 6 unicast routing. Corp config hash interface fast ethernet 0/0. Corp config if hash IP version 6 address 2001:db8:3c 4d:1:/64 EUI-64. Corp config ish hash IP address 29.168.255.1 255.255.255.0. IP version 6 routing protocols. Most of the routing protocols we've already discussed have been upgraded for use in the IP version 6 networks. Also, many of the functions and configurations we've already learned about will be used in almost the same way they've used now. Knowing that broadcasts have been eliminated in IP version 6, it follows that any protocols that use entirely broadcast traffic will go away of the dodo. The routing protocols that will still use in version 6 got a new name and a facelift. Let's talk about a few of them. First on the list is RIPng Next Generation. Those of you who've been in IT for a while know that RIP has worked very well for use on smaller networks, which happens to be the reason it didn't get whacked and will still be around in IP version 6. And we still have EIGRP version 6 because it already had protocol dependent modules, and all we've had to do was add a new one for it to be the IP version 6 protocol. Rounding out the group of protocol survivors is Ospf version 3. That's not a typo, it really is a version 3. Ospf for IP version 4 was actually version 2. So when it got its upgrade to IP version 6, it became Ospf version 3. RIPng, to be honest, the primary features of RIPng are the same as they were with Routing Internet Protocol version 2. It's still a distance vector protocol, has a max hop count of 15, and still has the same loop avoidance mechanisms, as well as using UDP port 521. And it still uses multicast to send its updates to, but in IP version 6 it uses FF02:9 for the transport address. This is actually kind of cool because in Routing Internet Protocol version 2 the multicast address was 224.0.0.9, so the address still has a 9 at the end in the new IP version 6 multicast range. In fact, most routing protocols go to keep a little bit of their IP version 4 identities like that, but of course there are differences in the new version, or it wouldn't be a new version, would it? We know that routers keep the next hop address of their neighbour routers for every destination network in the routing table. The difference is that with RIPng, the router keeps track of this next hop address using the link local address, not a global address. So just remember that RIPng will pretty much work the same way as with IP version 4. EIGRP version 6, as with RIPng, EIGRP version 6 works much the same as with its IP version 4 predecessor. Most of the features that EIGRP provided before EIGRP version 6 will still be available. EIGRP version 6 is still an advanced distance vector protocol that has some link features. The neighbour discovery process using hellos still happens, and it still provides reliable communication with a reliable transport protocol that gives us loop-free fast convergence using dual. Hello packets and updates are sent using multicast transmission, and as with RIPng, EIGRP version 6's multicast address stayed almost the same. In IP version 4 it was 224.0.0.10. In IP version 6 it's FF02:A, A equals 10 in hexadecimal notation. Last to check out in our group is what Ospf looks like in the IP version 6 routing protocol. Ospf version 3. The foundation of Ospf remains the same. It is still a link state routing protocol that divides an entire internetwork or autonomous system into areas, making a hierarchy. Adjacency neighbor routers running Ospf and next hop attributes now use link local addresses, and Ospf version 3 still uses multicast traffic to send its updates and acknowledgements. With the addresses ff02:5 for Ospf routers and ff02:6 for Ospf designated routers, which provide topological updates route information to other routers. These new addresses are the replacements for 224.0.0.5 and 224.0.0.6 respectively, which were used in Ospf version 2. Summary. This chapter covered the basic routing protocols that you may find on a network today. Probably the most common routing protocols you'll run into are routing internet protocol, open shortest path first, enhanced interior gateway routing protocol. I covered routing internet protocol version 2 and the differences between the two RIP protocols, as well as EIGRP and BGP, which is Border Gateway Protocol. In the next section on distance vector protocol, we also covered IP version 6 routing protocols and some advanced IP version 6 operations, including traditional mechanisms such as dual stacking and tunneling. I finished by discussing Ospf, ISIS, and when you would possibly see each one in a network. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.